Hello everyone, myself BB Sangme. So today we are going to discuss a problem of a simple harmonic motion with the roller follower. So before starting, please do subscribe for the latest updates of the theory of motion lectures. Okay. So here the problem is a cam with a minimum radius of 25 mm rotating clockwise at a uniform speed is to be designed to give a roller follower at the end of wall rod. The motion is described below. To raise the wall through 50 mm during 120-degree rotation of cam. So here we need to design the cam for the design the cam to operate the wall. So here the outward stroke is 120-degree and the lift of follower, that is nothing but the lift of that wall, is 50 mm. Second is to keep the wall fully raised through the next 30 degrees. It means that we need this is the dwell period for which the wall will be in the open state. Okay, so this is the dwell period of 30 degree at which the follower will be at the topmost position and at the stationary condition. Okay, third is to lower the wall during the next 60 degree. After at the end of dwell period, the return stroke will start. So this is the return stroke. It means that wall is going to close during this period. So this is and during this period the angle raised by the cam is 60 degree. And fourth is to keep the wall closed during rest of the revolution, that is 150 degree. So this is the last dwell period during which the follower will be at the bottommost position. It means that the wall will be closed for the bottommost condition of the follower, and during this period of 120-degree rotation of cam, the follower will be stationary. The diameter of the roller is 20 mm here. So during the last lecture we discussed the 9-phase follower. So here we are going to deal with the roller follower, and the shaft diameter is 25 mm. Okay, draw the profile of the cam when the first case is the line of stroke of the wall passes through the axis of the cam. So this is the case of radial follower. And second case is the line of stroke of the stroke is offset by 15 mm from the axis of camshaft. So this is the case of offset follower. So step by step we are going to, first we will see we are going to draw the cam profile for this condition, and next we are going to draw for the second condition. The displacement of the wall while being raised and lowered is to take place with simple harmonic motion. So during last video we discussed about the uniform velocity. So today we will discuss about the simple harmonic motion. So here we need to calculate the maximum acceleration. We need to determine the maximum acceleration of the wall rod when the camshaft rotates at 100 rpm. So we need to calculate maximum acceleration during outward stroke and return stroke, AO and AR. Draw the displacement, velocity and acceleration diagram for the complete revolution of cam. So here we need to draw the displacement diagram, velocity diagram and acceleration diagram. To draw velocity and acceleration diagram, we should determine the velocity during outstroke and return stroke. Similarly, we should determine the acceleration during outstroke and return stroke, and then and only then we can draw the velocity and acceleration diagram. Let us see what we have. We have outstroke of 120 degree. Next is followed by the outstroke dwell period. After that, return stroke is of 60 degree, and again there is a dwell period of 150 degree. The speed of cam is 100 rpm, so that we can calculate omega. The stroke of the follower, that is lift of follower, is 50 mm. Minimum radius of cam, this is the radius of base circle, and the radius of roller is 10 mm, that is small r. Okay. So next is here to draw the displacement diagram, we need to take some scale. So I have taken a scale of 2 degrees equals to 1 mm, because the distance we are going to plot the angles on a horizontal line. Okay, so 120 degree, if we will take a scale of 1:1, this will be 120 mm, this will be 60, this will be 50, and this will be 150. So it is very the length will be very large. So I have decided to take a scale of 2 degrees equals to 1 mm. So for the scale of 2 degrees is equals to 1 mm, theta O will be 60 mm, theta R will be 30 mm, dwell will be 15 mm, and remaining dwell will be 75 mm. So let us draw the diagram. So as per scale, first I will draw a line of length equals to near about 120 plus 30, 150, sorry, 60 plus 15, 75, 75 plus 30, 105. So at least we need to draw a line of length more than 105 mm. Okay, next draw a line parallel to this first line at a distance of 50 mm, because the lift is 50 mm. Here we have just reduced the angles. We are not supposed to reduce the stroke. Okay. So next is draw a line parallel to the previous line at a distance of at a height of 50 mm. So this is the stroke. Next is join this line. A and 0 are the points where the rotation starts. This is the initial condition, which represents the follower is at the rest condition. Okay. Next, take a distance of actually theta is 120 degree. For the 120 degree, we are going to draw a line equals to 60 mm. So at a distance of 60 mm, I have plotted one point which is called as H, and simultaneously I have drawn one line passing from H, vertical line. Okay. Next, for the period of dwell, the line 50 at a distance of 50 mm, there will be a point which is I. Okay. So H is the point where the outward stroke ends. Sorry. I is the point where the return stroke will start. Okay. Next, so this distance is actually 15 mm as per scale, and the next distance will be again for the angle of 60 degree. The return stroke will be of length of 30 mm. So let us plot the point at a distance of 30 mm. So this is A dash. So the distance between I and A dash is 30 mm. So I have completed one box at here. Okay. So this box, actually this larger rectangle represents the outstroke, and smaller one represents the return stroke, and middle one represents the dwell. Okay. So the next step is the remaining is actually the dwell period of 210 degrees. So we need not to show the complete dwell period. Okay, because during that period the follower will be at the rest position, at the bottommost position. Okay. So next is here we are going to deal with simple harmonic motion. So to draw the displacement diagram with simple harmonic motion, first we need to plot the center of the stroke. So obviously here this actually the height or the stroke length is 50 mm. So at the midpoint, at a distance of 25 mm, you need to take a center. After that I have drawn a semicircle of radius equals to 25 mm, which is the half of the stroke length. Okay. Next, I have drawn one line passing through the center of the circle. Similarly, I am going to divide this circle in 6 parts. So what am I going to do? I will take a distance equals to the radius of circle, means 25 mm. I am going to put the compass at point A, and I am going to create one arc at here. Similarly, I am going to put the compass at here, and I will create one. I am going to create one arc at here. Similarly, in this manner, for the this quarter also, I am going to put the compass at here. I am going to divide this part in 2 parts. Okay, so let us divide. So first is so put the needle at here, create one arc at here. Similarly, put the needle at here, create second arc. Similarly, you can divide this part also. So I have divided this. Similarly, I have divided the remaining quarter part of the circle also. So next is I am going to give the numbers from 1 to 6. So this is the part 1, this is 2, 3, 4, 5 and 6. So next step is I am going to draw the horizontal lines parallel to the axis or parallel to the base line. Okay, so let us draw the parallel lines. The next step is we need to divide the outstroke and return stroke in 6 parts. Okay, you can divide in also both 8 parts you can do, but 6 parts are sufficient here. Okay, so already we have discussed how to divide a line in the previous lecture, in the previous video. Okay, so to divide the here the length of outstroke is actually 60 mm. So one part to divide the 60 mm in 6 equal parts, one part will be of a length of 10 mm. So at a distance of 10 mm, let us plot point 1, 2, 3, 4, 5 and 6. So these are the 6 equal parts of outstroke. Similarly, for the return stroke, 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. Okay, so so here you can see that for the return stroke actually the distance is 30 mm. So the one part will be of a length of 5 mm. Okay, or you can use the method of you need to draw an angular line, you need to divide that angle, and the same procedure which I have explained in the previous video, you can follow that also. Okay, so next I am going to draw the perpendicular lines passing from every point. So let us draw a line from 1, 2, 3, 4, 5, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash. Okay, so next is here you can see that at the cross section of 1, 1 I'm going to highlight the point at the cross section of 2 2. So I'm plotting the points at the cross section of 3 3. Similarly 4 4, the point will be at here. Similarly for the vertical line 5 and horizontal line 5, it will be at here. For the 6 6, it will be at here. For the return stroke, it will be again at here. 6 6, 5 5, 4 4, 3 3, 2 2, and 1 1. Okay, so I'm going to give the names. I'm going to assign the names to these points in ABCD manner. So this is B, C, D, E, F, G, in the reverse manner: G dash, F dash, E dash, D dash, C dash, B dash, and I dash. Okay, so next step is we need to join these points by a smooth line, so that it will look like a curve. Okay, so I have joined these points of outstroke. Similarly here the dwell period is straight line will be there because the follower will not move, and return stroke will be like this. Okay, so this is the displacement diagram. So here we are going to calculate the we need to plot the velocity and acceleration diagram. So to plot the velocity and acceleration diagram, we need to calculate the velocity during outstroke and return stroke also, and similarly acceleration during outstroke and return stroke also. So let us calculate. So let us consider the angle of outstroke. The angle of outstroke is before that let us calculate omega. Omega is the angular velocity of cam. So here angular speed is 100 rpm. So for the speed omega is 10.47 radian per second as per calculation. We have used the formula of 2 pi n divided by 60. So let us consider the outstroke angle, which is 120 degree. I have converted the angle in terms of radian by multiplying I have multiplied it by pi by 180. So in terms of radian, it is 2.1 radian. So let us calculate the velocity during outstroke, VO. So the formula is 2 omega s divided by theta O. So by calculation, OVO is 0.39 meter per second. Similarly, acceleration during outstroke, AO is equals to 4 omega square s divided by theta O square. So by calculation, it is 6.13 meter per second square. So let us calculate the velocity and acceleration during return stroke. So for the return stroke, we have considered the given angle is 60 degree. I have converted the angle in terms of radian. Let us calculate VR. The formula is 2 omega s divided by theta R. Okay, the angle of return stroke. So by calculation, VR is 0.785 meter per second. Similarly, AR, let us calculate AR, acceleration during return stroke. It is by formula, by calculation, it is 24.67 meter per second square. So here you can observe that the velocity and acceleration during return stroke are less comparatively the velocity and acceleration during outstroke, because the displacement during outstroke is very you can see the displacement is of an angle of 120 degree, so the time required is more. So that is why the velocities and acceleration both are less. But during the return stroke, the displacement is very less. 60 degree angle of rotation is given to the cam, so the displacement of follower is very fast. So the velocity is more comparatively, velocity of and acceleration of return stroke is more comparatively velocity and acceleration of outward stroke. So here once again we are going to use these same values to draw the velocity and acceleration diagram. But before that, let me explain. Here you can see that the displacement starts at point A. So at this point velocity will be 0 because displacement is 0. As the cam rotates and follower moves up to point D, the velocity will be maximum at this point because the velocity goes on increasing. But after that, you can see that from the rest point, the follower moves to the up to point D, the follower attains the maximum velocity. After that, the follower goes towards the rest side, because at this point the follower will be stationary. Again, from the motion it is going to the stationary side. So at this moment the velocity will be maximum. Again at this moment, at the stationary condition, the follower is going to rest, so the velocity will be 0 at this moment. So at the moment of point 0, velocity will be 0. At point 6, velocity will be 6. But at point 3, velocity will be maximum. Similarly, for the return stroke, same thing will happen. At point G, means 6 dash, the follower will be at maximum position and it will be at the state of rest. So at this point, the velocity will be again 0 because displacement is 0. But when follower will move towards the downward side, it will have some displacement, so the velocity is going to increase. At point D, velocity will be maximum for the return stroke. Okay, after that again it is going to the state of rest, so it means that at point 0 dash velocity will be 0, because at point 0 dash the follower will be at the rest state of rest. Okay, so at the point of G and at the point of A dash or 0 dash, the velocity during return stroke will be 0, and at the point of D dash velocity will be maximum. So you can predict that it will be like a semicircle. You need to draw a semicircle of radius is equals to 0.39 during outstroke, and during return stroke it will be negative, because the velocity is actually decreasing. So it will be negative, and it will be of a magnitude something. During return stroke it is 0.785 meter per second. Obviously it is increased because the time required to trace the angle of 60 degree. Here you can see that the speed is 100 rpm. With a constant rpm, they have mentioned that the cam rotates with a constant velocity. So for the constant velocity, whatever the time required to trace the angle of 60 degree, as you can see that for during the outward stroke, the follower travels same distance of 50 mm, but cam rotates with an angle of 120 degree, so the time required is more, so that is why the velocity is less. But during the return stroke, you can see that the same distance is traveled by the follower from top to bottom, but the required time is less, because to trace the angle of 60 degree comparatively for the angle of 120 degree, 60 degree angle requires less time. So the velocity is going to increase because the time is less. Okay, so as similarly we are going to calculate the acceleration. So let us discuss in the next slide. So before that I have recreated the same image head here. So by using this image I am going to draw the first. Let us draw the cam profile for this, and afterwards we are going to plot the velocity and acceleration diagram at here. Okay, so let us first of all here let us point plot O from where I am going to draw the base circle. Here minimum radius of cam is 25 mm. So let us draw a circle of radius of 25 mm. So this is the base circle of radius of 25 mm. So this is base circle. Okay, next the radius of roller is something 10 mm. They have given the radius of roller. Actually the diameter of roller is 20 mm. So the radius of roller we have taken 10 mm here. Okay, so we need to calculate the radius of prime circle. So how to calculate the radius of prime circle? We need to do the summation of radius of base circle plus radius of roller. So total radius of prime circle is 35 mm. Okay, so next thing is draw vertical line, and on this line you need to take a point which is going to represent, which is also called as a trace point, which is going to represent the center of roller at a distance of 10 mm. Okay, because the radius of roller is 10 mm. So let us plot a point on this line. So this is the 10 mm distance, and about this point I am going to draw a circle which is going to represent, which is actually representing the radius of roller. Before that let us draw the prime circle. The prime circle is having radius of 35 mm. So obviously, okay, this is the radius of 10 mm, and this is 25 plus 10 means 30 mm. This is the prime circle of radius 35 mm. Next let us draw the roller of radius 10 mm from this center. So I have drawn the roller of 10 mm. Okay, so I will complete the roller follower. So this is the roller follower. Already we have discussed in the first video the difference between knife edge follower and roller follower. Okay, so this is the basic requirement to start the cam profile. But remember one thing, when we used to deal with a knife edge follower and flat face follower, there will not be any kind of prime circle. In case of only roller follower, prime circle will be there, and in case of a roller follower we need to plot every point, we need to divide a prime circle. We are not going to divide the base circle. But in case of flat face follower, knife edge follower, we used to divide the base circle. There will not be any kind of prime circle. Okay, so first step is I am going to join the line O. This is the point 0 or A, and this is the point 0 and A, where the profile of cam will start. Okay, so let us join this point. Okay, so I have joined this point O and A by means of a straight line. So first the outstroke angle is 120 degree, so you need to put the protractor at here like this vertically, and you need to measure angle in anti-clockwise direction like this. So at an angle of 120 degree let us draw a line. So this line intersects with the prime circle somewhere at here. So this is the point H. Okay, Next is the dwell period of 30 degree. Okay, here we have reduced the space, displacement diagram. We have took a scale of 2 degrees equals to 1 mm, but while drawing the cam profile, we need to take 1:1 scale. We are not supposed to reduce the cam profile. It should be with a scale of 1:1. Remember that. Okay, next is take the dwell period is 30 degree. So from this line, draw a line inclined at an angle of 30 degree. Okay, measure the angle in this anti-clockwise manner. So let us draw this point. At this point, this line intersects with the prime circle at here, which is going to represent the eye. So this is eye. Okay, next is return stroke is at angle of 60 degree. So let's draw a return stroke. From this line, we need to plot an angle of 60 degree, draw a line. So this is the return stroke, and this is the remaining part is from this line. This is actually point 0 dash and A dash where the return stroke ends. So this is the point. Okay, so after this is the remaining part of 210 degree, which for which the follower will be at the rest position. Okay, so next thing is we need to divide the outstroke and return stroke with same number of parts. Here we have divided outstroke in 6 parts and return stroke is also 6 parts. So to divide the angle of 120 degree in 6 parts, simply you can divide it, take an angle of 20 degree. So this is once again I repeat that we need to divide the prime circle, not base circle, because here we are going to we are drawing the cam profile for the roller follower. So we need to deal with only prime circle. Okay, so next this angle will be 20 degree, because here we are going to divide the 120 degree angle in 6 parts. Okay, so one angle will be of a angle will be of a value of 20 degree. Okay, next take the same distance in compass and you can plot the points 2, 3, 4, 5 and 6. Okay, similarly we need to divide this 60 degree angle in 6 parts, or as we have divided in this reverse manner. So this is 6 dash. So one part will be of an angle of 10 degree. So let us take an angle of 10 degree. Okay, similarly take the same distance in compass and you can plot these points. Okay, so this is 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. So finally we have divided the prime circle. Okay, next thing is as we have seen that first I have drawn the base circle, after that I have plotted the roller at here. So this is the line, actually it represents the stroke of follower. Similarly we need to draw the lines, stroke lines from every point which we have plotted on the base circle, sorry not base circle, on prime circle. So let us draw the lines from point 1, from point 2, it should pass from point O and from on the points on the circumference of the prime circle. So similarly, so again I have kept increasing the length of points as the number goes on increasing, and similarly in this way I am going to decrease the length of line as the number goes on decreases. Sorry. So I have drawn a line from every point on the circumference of prime circle. So these lines are the stroke lines on which we are going to locate the position of follower. So actually B, C, D, E, F are the position of the follower for the respective rotation of cam. For the 10 degree of rotation, the follower will be lifted at a distance of 1 to B. Okay. For the next 20 degree rotation, the lift of follower will be 2C. For the 30 degree rotation, it will be 3D. For the 40 degree, it is not actually, it is one part is of 20 degree. So this is the 20 degree. For the rotation of 20 degree, the distance will be 1B. For the rotation of 40 degree, it will be 2C. So lift, these vertical lines are actually representing the lift of follower, and these lines are representing the angle traced by the cam. Okay, so here the cam is rotating in clockwise direction. That is why we have divided. They have not mentioned any condition like that, but we need to assume some case. So here we have assumed that the cam is rotating in clockwise direction. So that is why we have divided the angle in anti-clockwise manner. So let us plot the points. Next, take the distance of 1 to B in compass, put the needle at point 1 and create one arc at here. So this is the point B. Okay, this is the point B. Next, take the distance of 2 to C in compass, put the needle at here, create one arc at here. This is the distance 2 to C. Take a distance of 3 to D in compass, put the needle. So every time you need to transfer the distance from here and you need to put the needle of compass on the prime circle. Remember that, because during previous video we have solved the problem of knife edge follower. So in case of knife edge follower, there will not be any prime circle, but in case of a roller follower, every time we need to transfer distance from this circumference of roller follower. So similarly 3 to D, so this is the distance 3 to D, take a distance of 4 to E, put the needle at here, this is the 4 to E. Okay, similarly 5 to F, put the needle at here, this is the 5 to F, and 6 to G, this is 6 to G. Similarly 6 dash to G dash, 6 dash to G dash, 5 dash to F dash, 5 dash to F dash, 4 dash to E dash, 4 dash to E dash, put the needle at 4 dash, you will get and create one arc at here, E dash. So similarly I have divided the remaining parts also. Okay. The next thing here, you can see that I have plotted the point A, I have drawn a roller at here. So this is the actually point where the roller, circumference of roller and circumference of base circle are actually in contact with each other. So at this point the motion, actually this is the 0 point, means this is the 0 point, and here on the circumference of the base circle this is the 0 point. So at this point the cam profile will start. So every time here you can say that when the cam will rotate, it will come in contact with roller somewhere on the circumference of the roller at the bottom side of roller. Okay, so what I'm going to do, I will draw the roller, I'm going to draw a circle from every center, from point B, C, D, E, F, G, similarly G dash, F dash, E dash, D dash. In a similar way, I'm going to draw a circle from every center of radius equal to the radius of roller. So actually the radius of roller is 10 mm. So first draw a circle, take center as a B, and let us draw a circle. Next similarly from point C, second circle will be there from point D. So D as a center, E as a center, F as a center, G as a center, G dash as a center, F dash as a center. So you have to draw a circle equal to radius of circle equal to the radius of roller, means you can take the similar this radius also. Okay, so you have to draw a circle from every point up to this point. Okay, so this is the start point of cam, profile of the cam, and this will be the end point of the profile of the cam. So what we have to do now, we have to draw a line which should touch every circle. Okay, like in this manner, which is going to represent the profile of the cam. So make sure that it should not intersect with the circumference. It will be tangent, okay, to the circumference of this circle. Okay, again it should not be wavy. Okay, it should not have peaks and valleys, otherwise the follower will be of a jumping follower. Okay, so you can use a French curve at here to join these lines to create a profile of cam. So let us draw the line, a profile of a cam. It will start at here and end at here. This is the outstroke, this is the dwell period. From this to this we need to draw a line like this. Okay, from this period to this period. Okay, so this is the profile of the cam. So here you can observe that to every circle I have tried to touch, but it is not intersecting with any circle. So the profile should be smooth, then and only then the execution follower motion will be smooth. Okay, so this is the profile of the cam. So next step is, as we have calculated the velocity during outstroke and return stroke, so let us plot the velocity and acceleration diagram here. So first we need to project the positions in vertically downward direction. Let us draw the lines from point 0, from point H, from point 6 dash, I dash and A dash. Okay, on this line I am going to draw the velocity diagram. Okay, so as we have calculated velocity VO during outstroke, as we have discussed that this is the velocity 0.39 meter per second. Okay, so as we have discussed that at point 0 the displacement is 0, velocity will be 0. As the cam rotates, the follower will attain, for the rotation of 20 degree, it will attain the position of B, C, D. So at point D the follower will have the maximum velocity, because after that again the follower is going to the rest position. So G is the rest position, A is the rest position. So at point D velocity will be maximum. So the curve will be like this. So already we have calculated VO 0.39 meter per second. So you need to convert this into some mm. you can take any scale. I have not mentioned any scale here, or you can draw a circle of a lump sum radius. You need to draw a half circle here. So I have drawn a peak here. The height of the peak is actually representing the velocity during outstroke. So here you can see that the point at point 3 the velocity is maximum, at point 0 velocity is 0, at point 6 because the follower is will be at rest condition during this period, so at this point the velocity will be again 0 because displacement is 0. From this period to this period velocity will be 0 because the follower will not move. This is the period G to G dash, during which the follower will be at the topmost position but it will be stationary. So this is the dwell period where during this period velocity will be 0. So here again during the return stroke, at this moment, means this is the point, the follower is going to move towards the downward side. Okay, so at this moment the displacement is 0 and the velocity goes on increasing, but you can see that here the follower is going towards the downward side. Okay, so the curve will be like this. So here we have calculated already velocity during return stroke, which is 0.785 meter per second. So here the value of VR is greater than VO. So again we need to draw a curve like this, but the height of or peak of curve will be more than this VO. Okay, so let us draw a curve. You can take a scale. You can consider this distance as you can take any scale. You need to convert the velocity in terms of meter per second into mm. So you can decide the height of that peak, these two peaks. So this is the velocity during outstroke. This is the velocity during dwell period, which is 0. This is the velocity during return stroke. So this is the velocity diagram. Okay. So let us draw the acceleration diagram. Similarly, I'm going to draw one more line. So on this line I'm going to draw the acceleration diagram. As here we can see that the velocity is maximum at this position. At this position velocity is 0. So acceleration should be maximum at this position, because acceleration is nothing but rate of change of velocity. So it means that the velocity acceleration will be minimum when the velocity will be maximum. But here you can see that as the follower goes on moving towards the upward side, the displacement will increase. So as the displacement increases, you can see, you can call it as velocity is going to increases. So at this point already we have calculated the AO. AO is actually the value of AO is 6.13 meter per second square. So again you need to take a scale of 1 meter per second square is equals to something mm to plot the acceleration diagram. So initially the acceleration will be maximum. Okay, so this is the height of you need to draw a vertical line equals to 6.13 meter per second square or equals to 6.13 mm. The scale whatever you want you can take. Okay, or you can draw any representative figure instead of taking scale for the velocity and acceleration diagram too. Okay, so I have drawn a line, green line here. Height of line will be 6.13 or whatever the scale, whatever scale you will take for the 1 meter per second square, whatever mm distance you will take, you need to draw that distance. Next, here you can say that the velocity is maximum at distance. At this position at point 3 the acceleration will be 0. Okay, again the acceleration goes on, it is the retardation because actually the speed is going to decrease. Okay, the part which is in motion, it is going from the state of motion to the state of rest. So this part should be negative. Okay, so this is also of the same height, but towards the downwards, actually it is the at the bottom of the line which is representing the acceleration. So next is as we can see that here displacement is 0 during the period of G to G dash, velocity is 0, acceleration will be also 0. So this is the acceleration 0 point. Next, here you can see that the follower moving towards the downward side. At the point D dash the velocity is maximum. Similarly at this point acceleration will be 0, and at this moment the follower will start to move. So the object is at stationary condition but it will move, means acceleration will be maximum. Okay, so already we have calculated is 24.67. so you for the scale, whatever scale you have taken, you have to convert the value of 24.67 meter per second square into that in terms of mm. So that much of height you have to take at here, and let us draw a curve like this. So similar value will be at here, because at the end again acceleration will be maximum. So this is the acceleration diagram for simple harmonic motion. Okay, So this is the first case, which is case A, where we have drawn the profile of the cam, we have calculated the velocity and acceleration diagram. Okay, displacement, velocity, this is displacement diagram, this one is velocity, this one is acceleration. So let us see the case B. So I have recreated the same image at here for the case of B. The diagram will not change, because here only the difference is that the first case was the of a radial follower, and this is the case of actually offset follower. Okay, so what we need to do in case of offset follower, the displacement, velocity, acceleration diagram, it will not change, it will be as it is. Okay, but only that profile of the cam is going to change in this case. So again, the first step is we need to draw the base circle of radius is equals to, here the radius of base circle is 25 mm, minimum radius of cam. So let us draw. Here I have plotted the center of the cam. From this I have drawn a base circle. This is the base circle of radius is equals to 25 mm, similarly as we have did in the last previous slide. Okay, so this is the base circle. Next step is I am going to draw the offset circle, because here they have mentioned that the line of stroke is offset by 15 mm from the axis of camshaft. As we have considered the cam is rotating in clockwise direction, and already we have divided the angle in anti-clockwise manner in the previous slide. So first I will draw the offset circle from the same point of radius is equals to 15 mm. So this is the 15 mm radius offset circle. Okay, next the question is from to which side the offset should be taken, whether we can take to the left side or right side. As we have assumed that the cam is rotating in clockwise direction, so that is why we have divided the angle, outstroke return stroke angle, in anti-clockwise manner. Okay, so here I'm going to again assume that the cam is rotating in clockwise direction. So when you will assume that the cam is rotating in clockwise direction, in that case you need to draw the tangent towards the right side. Okay, so let us draw a tangent to the circle in a vertical. I'm going to draw a vertical line at this point. Okay, so this is nothing but the stroke. On this line the follower is going to reciprocate. Okay, this is the axis of follower, so which is offset. Here you can see that in the previous case, axis of follower, I have drawn the axis of follower passing through point O. So which was the case of radial follower, where the axis of, this is the axis of cam, and in that case axis of cam and axis of follower were intersecting with each other, but here they are offset with each other at a distance of 15 mm. So on this point, okay, I'm going to plot the radius of roller, actually center of roller. As we know that the radius of roller is 10 mm. So we need to plot point A in such a way that the circle should only touch with the prime base circle. So let us draw a circle. So this radius should be 10 mm. Okay, make sure that not this vertical distance should not be 10 mm. This distance should be 10 mm. Okay, so first we need to draw a vertical line. Next you can take a distance of 10 mm in compass. You need to put needle at here, and by trial and error method you can plot the point A on this vertical line, on the stroke line. So after that after plotting the point, you need to draw a circle equals to the radius 10 mm. So this is the position of roller. So let us draw the follower. So this is the follower. So you might be identified the difference between the offset case and the radial case. So in case of radial, the follower will be exactly above the point O. In case of offset case, it will be towards the right side, or it will be towards the left side of the follower, actually center of the cam. Okay, so next I'm going to join line O and A by a dark straight line. Here you can see that. So after that you need to put the protractor. I'm going to divide the circle. So before that, let us draw the prime circle, which is the important on which we are going to plot the point. So this is the prime circle. Put the needle at here, take a distance is equals to OA in compass, and draw the prime circle. So this is the point O, this is the point A. Actually the point A is this is the 0 point, this is the A point. Actually this is the trace point. So from the trace point we need to draw the prime circle. Okay, next is put the protractor with the 0 line of the protractor should match the OA line, and measure the angle in this manner. You need to plot the angle of 120 degree. So let us plot the angle of 120 degree. Okay, so at this position there will be a second line, okay, which represents, this is the angle of 120 degree, which represents the outstroke. Okay, at this point I have plotted the point H at the intersection of this. Next, dwell period is 30 degree, so measure the angle of 30 degree from line OH. From this point we need to draw a line of 30 degree. So this is the 30 degree angle which represents this is the dwell period. So at this I have plotted point I. So this is the point I. Next, we need to plot the angle of 60 degree theta r. So let us measure the angle from this line towards this side in anti-clockwise direction manner of angle of 60 degree. So this is the angle of 60 degree. So at this point I will get 0 dash and a dash. So this is the end of the return stroke. So finally we have located A, H, I and A dash. Okay. So next thing, as we have divided in the previous slide, we have divided the outstroke with 6 parts and return stroke in also 6 number of parts. So let us divide. One part will be of a 20 degree for the outstroke. So take a distance, an angle of 20 degree. First point will be there. Take this distance in compass and transfer on this, and so divide this circumference in 6 equal parts. Similarly, 1, 2, 3, 4, 5, and this one is 6. So similarly, you need to divide this 60 degree angle in 6 parts. You can take an one part equals to 10 degree. So this is actually 6 dash. At here 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and this is 0 dash. Okay. So finally we have divided the outward stroke and return stroke in 6 equal parts. Okay. So next thing is, as we have after drawing the base circle, the first step was we have drawn the offset circle, and after that we have drawn one vertical line tangent to offset circle. This is the stroke line. So the basic difference between offset follower and radial follower is, in case of offset follower, the axis of follower will not intersect with the axis of cam. Here you can see that this is the axis of cam, this is the axis of follower. But in case of radial follower, it intersects with the axis of cam. Okay, so every time we need to draw a stroke line which should be tangent to this circle. It means that it should not intersect this circle. Okay, so let us draw a line passing from point 1, and it should be tangent to this offset circle. So I am going to draw a line like this. Similarly, line passing from point 2. So every line, line which I have drawn from every point, it is tangent to the offset circle. Okay, so this is the tangent. So these are the 6 tangents on which I am going to plot the point B, C, D, E, F. So these are the stroke lines, but remember that these stroke lines are not passing through the center of the cam. These are the tangent because we are dealing with the offset cam. Okay. The next is let us draw a line for the return stroke. We need to draw the stroke lines from the 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, and last one is, that is 0 dash. Okay. So finally here you can see that as the number goes on increasing, I have reduced the length of stroke lines. Similarly, as during the outstroke, I have increased the length of stroke line as the number goes on increasing. Okay. So let us transfer the distance. Take a distance of 1 to B in compass. Okay, put the needle at point 1, transfer the point BH here. Okay, create one arc at here. Take a distance of 2 to C in compass, put the needle at 2. Again I am transferring here distance from the prime circle. Okay, next is take a distance of 3 to D, put the needle at point 3. So similarly I have plotted every point on the stroke line. Similarly G dash, take a distance of 6 dash G dash, plot this. Take a distance of 5 dash F dash, 5 dash F dash. Similarly 4 dash E dash, 4 dash E dash, 3 dash D dash, 2 dash C dash. So similarly I have plotted these points on the stroke lines. So these are the stroke lines. So next, what we have did in the last slide, we have drawn a circle of radius equals to the radius of roller from every point. So let us draw, I am going to do the same thing here. So let us draw a circle of radius equals to the radius of roller from point B, C, D, E, F, G, and similarly from point G dash, F dash, E dash, D dash, C dash, B dash, and A dash. Let us draw the circle. Take B as a center, draw a circle. Take C as a center. So every time you should not change the radius of circle. The radius of circle is actually equals to the radius of a roller. So here I have drawn the roller. Okay. From every point I have completed the circles. I have drawn the rollers. up to point A dash. Okay, so next thing is, again we need to draw a profile of cam which should touch every circle. It should not intersect, and the profile should be smooth. The curve should be smooth enough so that the follower will execute its motion smoothly. It will not get jam inside the guide wires. Okay, so let us join the you need to draw a curve which should touch every circle of every circumference of every circle of the roller. Okay, so let us draw a line. So this is the profile of the cam. Here you can see that I have tried to touch every circle. Again, the line should not be wavy. It should not have the peaks and valleys, otherwise the motion will not be smooth. It will be of a jumping type. Okay, so this is the profile of the cam for the offset follower. So that's it for today. Thank you.